See Lindelof videos. Expected value. This is actually from AP Stats. So let's take a quick look at this. We have a $20 bill, two $10 bills, three $5 bills, and four $1 bills placed in a bag. And we're saying if we reach in that bag and randomly choose one of the bills, what is the expected value of the amount chosen? So this is kind of weird because, well, we'll see the answer is not any of these values, but it's expected value. And we're going to talk about how that helps us to make good decisions. So look, we have one $20 bill, right? So we have one $20 bill plus two $10 bills, two $10 bills, plus three $5 bills, plus four $1 bills. So all of a sudden, this at first this does not look any good because this doesn't look like a truism. But look at this. As a percent, we have, look, 4 plus 3 is 7, 9, 10. There are 10 bills in there. So if we look at it this way, I think we can agree that 1/10 of those are $20 bills. 2/10 of those are $20 bills. 3/10 of those are $5 bills. And 4/10 of those are $1 bills. I'm going to check my math here. 1 plus 2 plus 3, 6. 6 plus 4 is 10. 10 tenths have them all accounted for. Well, this is exactly how this works. So what we're going to do is this. We're going to multiply this. I actually did it on my calculator. I have my calculator up. I did this out on my calculator. So I obviously come up with 20 over 10 here plus 20 over 10 here plus 15 over 10 here plus 4 over 10 here, right? When I add all of these up, when I add up all these numerators and divide, I get $5.9. So the expected value in this game is $5.9. But you're like, Charlie, there's not a $5.9 bill there. That's actually not how this goes. We're talking about an infinite population, right? Because we can play this game as many times as we want to play this game. There's no limit to it. So in general, what would your expectation be? So you say, what am I supposed to say about this? What you're supposed to say about this is, if they let you play this game for $4 per game, should you play? Sure, because the expected value is 5.9. That is to say, the expected payout is greater than the amount that you pay to play. What, however, if they said to you, pay $6 every time you play? Should you play? Probably not, because in a large experiment with many, many trials, the expected payout is $5.9, so $5.90. So you're going to be losing money, right? So that's kind of how this works. I'm going to do a couple more examples. I hope this is helpful. I'm going to do the next one on the calculator so you can see it there. If you have any questions or comments, please let me know. Thanks for watching, guys.